Hello and welcome to Centre UB's webinar in June this month. Today we have a really hot topic, and we're thrilled to have Ian Appley, a Professor of Cognition and Development, join us today. Ian is the Director of the Centre for Developmental Science, and he's an experimental psychologist studying social understanding, and his interest in neurodiversity stems from studying variation in social understanding. Today, he's going to talk to us about transdiagnostic approaches to neurodiversity. What we'll do is we'll hear from Ian, who'll deliver a talk and an overview of this topic, and then we'll have the opportunity for Q&A at the end of the session. If you have any questions, do pop them in the Q&A, and we'll ensure that we try to answer as many of those as possible. But I'd just like to extend thanks to Ian for joining us today, and I'll hand over to him for a very enjoyable presentation. Thank you.
Great, thank you very much for having me. Can you see my slides now? Is that working okay?
Yep, fine. Thank you.
Great, good. So what I was hoping to do today were a couple of things. So I know we have quite a mixed audience, and I was hoping to start out with a sort of very general introduction to different approaches to thinking about neurodevelopmental conditions, and sort of where this term neurodiversity and the ideas of neurodiversity are coming from. And then I'm going to dive into a piece of research that we've done. And really, I guess some people are going to be interested in some of the specifics of the research, but what I really want to use it for is as a tool to get people thinking about what neurodiversity might mean, how we might study it, and how we might be able to think about it outside of a scientific context as well. So I'm extremely open to any questions that people are going to have any aspect of this. But as Victoria said at the beginning, I'm a researcher who has an interest in neurodiversity, but I'm not a neurodiversity specialist. And I think that hopefully gives me a sort of a slightly different perspective from one that you might get from reading some of the standard literature. Okay, so I wanted to start out with I guess a bit of a historical take on when I was learning about neurodevelopmental conditions at university. It was very much a sort of traditional perspective of thinking in terms of specific conditions like autism, ADHD, dyslexia, dyspraxia, Tourette's, that were neurodevelopmental conditions that were early developing, so a very strong focus on childhood, and that these were conditions that were really considered to be discrete or distinct from one another. And that was reflected in diagnostic criteria, which was sometimes exclusive. That's to say, you couldn't have one condition if you had one of the other conditions. And over the past 30 years or so, I think that picture has been changing for a variety of reasons. Why is that not advancing? Okay, here we go. So I'll talk you through the graph in a moment, but there's, I guess, a growing neurodiversity perspective in science, and that's allied with the neurodiversity movement, a sort of social and political movement that's founded in advocacy. And both of those things are changing the way that we think about the neurodevelopmental conditions quite dramatically. So let's start with some observations. So one of the sort of driving observations here is that although the traditional perspective would see autism, ADHD, dyslexia, dyspraxia as discrete conditions, as distinctive conditions, there's actually very high variability within particular conditions. So someone with a particular diagnosis might be very different from another person with a particular diagnosis in a variety of ways. And another key observation is that although where we're coming from here is, if you like, a clinical tradition of diagnosis and categorization, there's actually very good evidence that lots of the characteristics that you might associate with a particular neurodevelopmental condition vary across the whole population. So if we look at the figure here, what we're looking at is the total score on a questionnaire where people report, and these are adults, reporting traits associated with autism. Okay, and these would be things about, often about preferences for different kinds of social activity or different kinds of interest or focus, ways of doing things. And what you have in the solid line is people who have a diagnosis of autism, and in the dotted line, the dashed line, people without a diagnosis. And what you can, I think the striking thing to see here is, well, two things. First of all, very substantial overlap between, so maybe the most striking, one important thing is that people with an autism diagnosis, on average, score higher. Okay, so the average about here is higher than the average about here on these traits. But nonetheless, there's a very significant degree of overlap between these two groups of people. And people with autism people with an autism diagnosis show traits across a really wide range that overlaps with a large part of people without a diagnosis. And this is, that goes alongside some other important observations, which are that actually, whereas in the traditional view, diagnoses are often considered discrete or even exclusive from one another, there's actually very high rates of co-diagnosis between conditions. So actually, if you have a diagnosis of autism, you're actually very, very much more likely than the general population to also meet diagnostic criteria for ADHD, for example. And the clinical observation that goes alongside these things is that conditions, so people with a diagnosis, often have distinctive as well as overlapping features. So things that you would think of as associated with autism, for example, some of those things are quite strongly overlapping with things you might expect to see in some other conditions as well, whereas some are more distinctive. And a final observation, which is quite a big change from when I was studying, and these were seen as, if you like, developmental conditions with an emphasis on early childhood, is that these are conditions that continue across an entire lifespan. And there is an increasing interest and focus and recognition that there are needs of people beyond childhood as well. Okay, so that's a very broad sort of outline of traditional versus neurodiversity perspectives. I want to say a few words about terminology, and this is somewhat fraught. There are quite important, well, quite extensive discussions of preferred terminology, and terminology evolves over time. One way that I've tried to approach this is just to, in a very common sense way, to realize that in any group of people, including the group of us here today, there's very likely to be people who have a diagnosis of one or more neurodevelopmental conditions, and people who have friends or family with a diagnosis as well. The traditional perspective on neurodevelopmental conditions very much is somewhat othering. That's to say, it sort of categorizes people and sees them as a separate category from the rest of the population. And I think what a neurodiversity perspective encourages us to do is to think in terms of us as a population of people, which includes people who might meet diagnostic criteria for a neurodevelopmental condition. So putting it simply, we should be thinking in terms of us and not they. Okay, more specifically, we need a bit more precision for talking scientifically about this, and I hope this terminology aligns pretty well with a lot of the preferences that are out there in the various advocacy groups working in different neurodevelopmental conditions. So when we're talking about neurodiversity, we can use that to describe variation across the whole population. And this is it's kind of an important point because it can be confusing, because neurodiversity is sometimes used to refer specifically to people with a diagnosis. And actually, it makes much more sense to think of neurodiversity as variability across all of us. Okay. a common distinction then is to say, well, for those people who don't have a diagnosis, unless they should have a diagnosis but don't have a diagnosis, for the rest of us, those people might be referred to as neurotypical. And then as you move further away from, if you like, the average of a neurotypical group, you might say that that is neurodivergence. So you have divergence from neurotypicality. And that ends up with a sort of new bit of terminology for people who have a diagnosis being described as neurodivergent. And this is terminology that's widely adopted by advocacy groups as well as in the scientific literature. But I think it's nicely illustrated by this idea of variability across the whole population with differences in those distributions. Okay, so that's a bit of background. What I want to do now is dive into the study that we conducted. And I want to say at the outset here that it's very important for us to keep in mind that this is a study of neurodiversity across a community sample of almost 1,000 British adults. Okay, so this is not a study of people specifically who have a diagnosis. So among those 1,000 people, of course, there were people who had a diagnosis, and we do know who those people were. But everything I'm going to be talking about here is really about neurodiversity across the whole population. So we sampled online 1,000 British adults, and they completed a bunch of trait questionnaires. So these are questionnaires that have been devised by clinicians specializing in different neurodevelopmental conditions, and they're designed to try and pick up on this variability in the experience of the experiences, preferences, strengths, and limitations that are traditionally associated with these different diagnoses. So we had trait questionnaires associated with autism, ADHD, dyslexia, developmental coordination disorder, tic disorders, Tourette syndrome, subclinical epilepsy. So that might sound a bit surprising, but actually that corresponds to a whole bunch of experiences that people who have epilepsy might experience more frequently than other people. So that might include things like auras, migraine type experiences, visual disturbances, and a further questionnaire about sensory sensitivity. In addition to those neurodiversity questionnaires, we also assessed people's nonverbal ability, so roughly speaking, IQ, their self-reported executive ability, that's mental flexibility, and also self-reported depression, anxiety, and well-being. So, okay. So this is a slightly complicated diagram. We're going to have a few of these sorts of diagrams, but I hope this sort of summarizes in a somewhat intuitive way what it was that we actually have then. So what you have is a bunch of questionnaires corresponding to these different conditions. Okay, and each of those questionnaires has some subscales. So for example, in the case of the autism questionnaire, there's a subscale associated with social experiences, one with routines, one with imagination, one with numbers and patterns, for example. And that's the same for each of these other questionnaires as well. They have subscales associated with them. Okay, so that's a sort of diagram of what we started out with. So sorry, so people do all of these questionnaires, and then I'm going to show you an indecipherable diagram here. So this is a correlation matrix of people's scores across all of those questionnaires in relation to one another. I'm not expecting you to read this, but what I think you probably can do if you squint and you see these numbers and the little asterisks next to them, and what that's telling you is that almost every single one of those subscales correlated with almost every single other subscale. Okay. Now, for those of us who are involved in psychological measurement, that is an absolute nightmare, because what it means is that these don't look like they're necessarily measuring particularly distinctive things, even though they set out to do so. Okay, so we can try and test then what structure there might be in these kinds of data. These are theory-driven models, but they're models that correspond to, if you like, extreme possibilities given what we set out to do. So one possibility, perhaps the one that the literature would be most happy with, would be to say, well, we've got each of these questionnaires, and the best fitting model of the data is one that says, well, that questionnaire has 4 subscales and they hang together better than they hang together with anything else. And likewise for all of the other questionnaires. So that's to say the questionnaires are testing things that are distinct from one another. The other is the sort of nihilistic alternative, which says there is no structure to these data. All of these questionnaire subscales load onto the same underlying factor. They're just correlated with each other. There's nothing else going on. And these models are variants on those 2 conceptually very distinctive models, right? So one says the original questionnaires are right. The other one says they're so completely wrong, there's nothing more going on. They're just all correlated. None of these models provided good fit for the data. Okay, so neither of these general positions nor these variants on them turn out to be correct for the data that we have. So what we then did was to say, okay, well, let's let the data speak. So for those of us who are familiar with these things, we did exploratory factor analysis on half of the data. So we took randomly allocated half of the sample and then looked at what was the best model of those data. I will talk you through the model in a minute. But the important point is we did the exploratory on half of the data. We then tested that model in the second half of the data to check that it was also a good fit in an independent set of data, and it was. And so the rest of the analyses were done on the combined data. And what we have here are 4 factors now. These are no longer the simple questionnaire factors. These are 4 factors. And it's something I'm going to keep talking about here is that these were set to be orthogonal to one another. What that means is, we can think of this in different ways. What that means is that they're independent from each other. So you can have a score on this factor that, whatever your score on this, you can equally well have a score that's high or low on any of the other factors. If you prefer to think of that visually, if you think of a standard XY plot, or in this case an XYZ plot, that's 3 dimensions. What it means is that each of these factors, wherever you are on one of them in this dimension, you could be anywhere on that dimension and anywhere on that dimension. Okay. Only we have 5 dimensions here, so unless your visual imagination is a great deal better than mine, that there's a limitation to how far we can extend this way of visualizing the data. Okay, so we have 5 orthogonal factors. And if we have a look now at these next to the meanings for each of these subscales, what we have is a bifactor model. And what that means is we have one factor, which we called N for neurodiversity, that basically is related to all of these questionnaires. So this is capturing the horrible correlation matrix that I showed you before, which is showing that actually there is a very strong relationship among all of these factors, okay, all of these subscales of the questionnaires, such that if you are high on one of them, you are quite likely to be high on any of them or all of them. But in addition to that, so you can think of this as, if you like, controlling for this factor or independently of that factor, there was also variation in 4 other factors that actually correspond to some of the original questionnaires. So we call this factor A because it loads strongly onto 3 of the 4 factors from the autism questionnaire. Factor B, the naming doesn't work out quite so well for this, but factor B corresponds to all 3 of the ADHD subscales, factor C to the epilepsy, subclinical epilepsy subscales, and factor D combines variation from the dyslexia and the dyspraxia subscales. So there's one factor that's sensitive to variation in all of those. Okay, and these are separate factors that can vary independently of one another. Okay. A little bit more on the specifics here. So this one thing that you want to check when you've run lots of questionnaires is that this isn't, we haven't just reinvented the wheel somehow. We haven't just found a fantastically new complicated way of assessing something general like nonverbal ability or mental flexibility. And so we checked that this wasn't redundant. We still get this model when we control for nonverbal ability or executive function. Okay. These factors turn out to be relevant in the sense that some of them were related, so especially the N factor, were related to mental health and well-being, especially the depression and anxiety factors. And among the things that we were looking to predict, all of the factors predicted something, but none predicted everything. That's to say, they were selectively useful in explaining other variability. So it really was the case that if you are high in N, that would explain some things, but not everything about your experiences of mental health and well-being, and likewise for the other factors. So it seemed like not only was this a good fit for the data, but it seemed useful to have these separate factors because they explained different things. Okay, so stepping back a little bit from the specifics, what does this actually mean? Well, for I guess for researchers or for anyone else who's interested in using some of these quite readily available measures, these questionnaire measures of, if you like, autistic traits or ADHD traits, there's quite a sobering conclusion, which is that if you use any one of these, let's just take the autism one, for example, what that's mainly measuring is variability that is in common across all of these things. So it's mainly measuring neurodiversity. Okay, so you cannot use the autism scale to assess autistic traits and not ADHD traits. Okay, you can only assess something more specific if you assess all of these things at the same time and then use a model like this to factor out the common variability. Okay, when you do that, then you can measure the specific variability associated that you might associate with autistic traits. Okay, so that's really quite important from a measurement point of view. So it's not that there isn't specificity, but it's that you can't see it when you just use individual questionnaires. If you use them in combination, then you can. And also, for those coming from a more social science background who might be interested in intersectionality and how these traits are expressed differently according to other characteristics such as gender or ethnicity, you can use a modelling approach like this as a way to think of some of those things in a quantitative way. Okay, let me try and make this a little bit more concrete, because I think it seems very abstract when you think in terms of these kinds of models. So let's imagine, I can get rid of this so we can see what's at the bottom here. Okay, there we go. So if we think in terms of individuals and how this captures, remember what I said about the beginning about this sort of complexity of neurodiversity, this observation that you see in people with a diagnosis, lots of variability within conditions, lots of co-diagnosis between conditions, and some commonality between conditions as well. So the idea is that this modelling approach can capture some of that. So we imagine one person who has high sensory sensitivity. Okay. Because that loads exclusively onto this general factor, what that means is that someone who's high in sensory sensitivity is likely to be high in lots of these other things as well. Okay, so that's what the statistical factor means is that a high score on one of these things is likely to be related to a high score on the other things as well. So that's a fairly, if you like, a specific finding here actually suggests a much more general set of likelihood that you experience high rates of a variety of other things as well. In contrast to that, imagine a person, another person who has high social difficulties. So where are we here? Social difficulties. So social difficulties loads quite highly onto the A factor. Because it loads highly onto this, it's going to be strongly associated also with high routines and high score on the imagination subscale, which is actually, because this is trying to capture a broader autism phenotype, and autism is associated with limited imagination, that this would be a limitation in imagination, but it's a positive score on that subscale. Okay, so high on one, high on these things, but just because you're high on this, it does not mean that you're any more likely to have high sensory sensitivity. Okay, you may or may not have high sensory sensitivity. It certainly doesn't rule it out, but you're as likely as not to have sensory sensitivity just because you have a high score on the social factor. Okay, so I hope you can see that that's a different conclusion from if you have high sensory sensitivity, then you are more likely to have a high score on the social factor because these things are associated. Okay. Person 3 has high reading difficulties, so that's a high score here. And so we can think here that could be for one of two possible reasons. So reading difficulties is associated with both the D factor here, which is associated with reading and motor skills, but it could also be because they're high in the N factor. Okay, whichever of those is true, it could be some combination or it could be one or the other. You would expect also to see motor difficulties. Okay, but if it's because they have a high D factor, that would only predict high motor difficulties. Whereas if it's because they're high on the N factor, that would predict that they have difficulties across the range of these scales. So I hope this gives you a sense that this kind of modelling approach can do some justice to the complexity of phenotypes associated with neurodevelopmental conditions, in this case in data from the whole population. Okay, I'm gonna have one more try at giving a sense of what these data are telling us. So I've been stressing this idea of orthogonal factors, and I think they are valuable for helping capture complexity. They are also quite counterintuitive. They're quite hard to visualize. So what I want to do is just try a different way of visualizing the data that I think maybe give us a slightly more intuitive feel for what we're talking about here. We can think of the data rather than as these factors as a map. So I think the way to think about this is imagine that you and I both did all of these questionnaires and filled them in ourselves. We would get scores for these different subscales and scores for each of these factors. We could then calculate, as it were, the distance between you and I on each of these factors. Okay, so we can then see, as it were, how similar or different we were in terms of our distance across these 5 different factors. And what we can then do is take exactly those calculations and turn it into a 2D map. So the 2D map just makes it easier to visualize because we can't visualize things in 5 dimensions. What we're doing is just saying we're going to use 2 dimensions to just represent the difference between you and me. Okay? And if we do that for the whole sample, so your data would be a dot somewhere in this cloud of variability. So when we're looking at this, and so would my dot. So what we can say is that, as it were, the distance between these two people are equally similar as 2 people who are similarly distant from one another. But because of their position in this 2D space, although their similarity is similar, they're going to have different experiences, different profiles of strengths and difficulties across those scales. Okay, so what this does is just give a representation of the variability that we're seeing in our data, but seeing it in 2 dimensions rather than 5. So there's a couple of features that I want to highlight here. So one is that there is quite a big spread in the data. There's a concentration of the data towards one side. So that's to say that a lot of people are relatively similar to one another. And then there's quite a large number of other people who are more varied. Okay. And then these dimensions are abstract dimensions. They're not themselves meaningful, but we can start to interpret them by either by relating them back to the different factors, or in this case, what I've done is to plot in the people in our 1,000 sample who self-identified as autistic, or as having ADHD, or as neither. Okay, so as you can imagine, with the prevalence of autism and ADHD, the majority of people self-identified as neither. But what you can see is, first of all, that the autistic and people with ADHD are distributed within the rest of the population. There's no clear boundary separating those people. However, you can also see that there's probably a trend towards more that people with ADHD being more likely to be in this direction, if you like. It's quite hard to indicate direction with a mouse, but over towards this side of the diagram, there's probably some sort of gradient in this direction for people being more likely to have to self-identify as autistic. But nonetheless, they're distributed within the population. So that's to say that these 2 people here are going to be scoring very similarly across all of the questions that we asked them, but one of them has a diagnosis of autism and one of them doesn't. And likewise for even people here who are at quite the extreme of the distribution, at least for some of the scores that they're giving. Again, we've got people with ADHD and autism and people with no diagnosis. So there's considerable overlap. I really don't want you to take away the conclusion that this invalidates diagnosis. That's not what these data mean. It's not what we're arguing for here. But I would be happy if anyone wanted to pick that up in the discussion. What it's showing is that in terms of people's self-rated experiences, strengths, and difficulties, the overall story is one of overlap in this population sample. So bringing this together, we have the traditional perspective and the neurodiversity perspective. And I hope that what I've done is to try to put some flesh on the bones. So if I think neurodiversity is a group of ideas and observations, and I think what we've been trying to do is say, well, if we have this high variability within conditions and continuous variability across the whole population, and high co-diagnosis and distinctive and overlapping features, how can we think about this really complicated set of phenomena? What I hope I've convinced you is that you can try and do justice to this complexity in a way that doesn't just say it's all very complicated and everyone's different, but there is structure in the data. There are ways of looking at the data that let us understand that structure, that respects both the variability and the distinctiveness that we see in the data and in the lived experience of people who have diagnoses. I think I have one last slide. So I hope I've convinced you this is a way of working with complex phenotypes. This is not the one answer. It's not the one way of doing everything. I think it's a potentially valuable complement that wouldn't replace detailed individualized analysis or approaches that look on both qual and quant information from people. But I think it provides a framework for thinking about the variability and complexity that we see. I think another thing that we might want to think about in a discussion is that it kind of highlights this tension that exists in the political advocacy movement for neurodiversity, which emphasizes correctly diversity and complexity as real parts of the phenomenology here. and at the same time views diagnosis as an important source of identity. Now, this is not to say that we have to choose between these things, but it's interesting to think about how these things fit together, given the picture that seems to be emerging here. Okay, and with that, I will stop and pause for questions. Thank you.
Thank you ever so much.